If you have a requirement for matching two impedance levels of different circuits, then there's two choices. Choice number one is a lossless uh, matching circuit, which is quite often transformer based or transmission line based. Another solution is to use attenuation, and the program is offering the possibility to calculate and investigate how you can match two different impedances based on a pi attenuation circuit, which is this example, or just try to find out how many loss you have to insert to improve the VSWR or the reflection in case of a circuit where you have a VSWR, you insert attenuation and calculate the improved VSWR because of the attenuation between the bad load to the generator. We concentrate on this version in this video, and in another video we will have a look at the VSWR improvement. So what do we see on this in this window? This is the attenuation and resistive impedance matching calculator. This is the input side, and here you found the output side. On the input we have a impedance level of 50 ohms. There is a power level at 0 dBm at present, and we are at the moment looking to a load which is 50 ohms. So let's change this one to a 100 ohm impedance. So the requirement is match 50 ohms to 100 ohms, making use of resistors. The first step what you have to check here is that the minimum attenuation to match this 50 ohms to the 100 ohms on the output is the minimum required attenuation level. And you see that here. And that's calculated to be a number of about, no, not about, exactly 7.66 dB. Now, initially the requested attenuation is set to 10. This means that requested is more than minimum, which makes it compliant to the requirements. Now let's say if we reduce this one to, for example, 5.8 dB, so which is less than the minimum required attenuation, a warning is given. Your attenuation level is lower than the minimum required attenuation. So let's go back here to 10 dB. So if we increase here to 30 dBm, equivalent to 1 watt input level, on the input box, here you see that the voltage, the RMS voltage, root mean square voltage, is 7 volts, and the peak-to-peak voltage is 20 volts. After passing through this attenuation, going into the load impedance of 100 ohms, you see that the calculated attenuation here, that's a check, is indeed 20 dBm, the output power, so that is 30 minus 10, giving you 20 dBm. The output impedance is 100 ohms, and giving you an RMS output voltage of 3.162 volts RMS, and peak-to-peak 8.944. The values of these three resistors are shown here: resistor 1, resistor 2, and resistor 3. And the corresponding powers which are dissipated in each individual resistor is found in the boxes below. So the 68.9 ohm resistor has a dissipation of 0.725 watts or 725 milliwatts. Total dissipation, what we find here, is 0.9 watts or 900 milliwatts. So this is how you can work with this calculator. It is very flexible. You can even turn the whole situation around. Let's say if you have a 50 ohms here, and if your source impedance is 100 ohms, the whole calculation is reversed. And then you can see what's happening with the calculation in this case. So you see this is higher voltages because the impedance is higher. And then you attenuate to match the 100 ohms to the 50 ohms. Okay, so this is the attenuation and resistive impedance matching calculator. Thank you very much for your attention.